So we only have a little bit of time left, and I definitely want to make sure that we get to see some of these really interesting slides, Oscar, that you brought in. Would you mind going over a couple of those? And I may jump in just to describe them visually for our
Yeah.
audio listeners, but otherwise I would love to see what's in those.
Yeah, probably should have kind of showed them a little bit earlier, but this is just an illustration of what's happening in software supply chain attacks. So basically, I think the first software supply chain attacks were in 2003, but there's is on such a small scale that they basically have disappeared into the axis here. The first, I think, really kind of bump up was in 2016, and that was a very interesting year, because there was actually a professor at university who claimed, well, software supply chain is way too easy to attack, and he actually made his point by producing an attack that was very successful. It was totally innocent. It wouldn't really do any damage or anything, but it proved his point, and clearly registered here, as you can see. And what he was saying was effectively true. I mean, he was a visionary, and we've seen kind of exponential escalation after that, right? That's
from 2020 to 2022. It's off the map. It's off the chart almost.
Yeah, and so now you're basically getting to the stage where governments are intervening, because it actually is doing quite a lot of economic damage. And also, I think from a security perspective, I think that's also a motivator for governments to deal with this. And I think the US is clearly, as you mentioned, taking the lead. But I think there probably are things ongoing in terms of diplomacy, because I know that I'm actually participating in the CISA work group on SBOM as an example, and I know that a lot of kind of officials are traveling to other countries to kind of spread the word, right? So there's a clear kind of diplomatic efforts to influence their allies and partners to also step up for sure. Yeah.
What is the x-axis here? Just the number of occurrences?
That's the number of attacks that's being reported. It is very difficult to get really good data, so the number of incidents is kind of the only thing. I mean, what you really would like to know is, well, what was the damage related to these incidents, but there's no it's very difficult to get good metrics on those.
It makes you think, because I remember back in the late 2000s, the places I worked at, we used tons of open source software and packages, and we asked ourselves in the security team, we're like, hey, isn't it obvious that this is written by people we don't know, and someone could take over that project and put malicious stuff in there? Everyone's like, yeah, that seems to be obvious. But like, no one did anything, and no one was taking advantage of it, as you were showing in that graph. It wasn't until 2016, and I wonder what instigated that. I mean, it's not that, like, sure, there's more software in use, absolutely, there's no doubt about it, but is it just that someone just thought about it and no one had done it, taken action to do it? And what other things exist in cybersecurity that are just sitting there waiting for someone to just start doing that?
Yeah, well, I was going to say, I'm kind of surprised that it took attackers so long to figure it out.
No, but that's normal, because like going back to our story about debit card skimming, like in 1991, there was the first incident. It took more than 10 years before it really, incidents really started to kind of escalate and started hurting people. And why this 10-year lag? Well, effectively, criminals are by definition lazy, right? They're not going to invest a lot in R&D and do complicated things, because otherwise they probably would have a regular job, right? So you almost need to kind of a whole industry needs to be developed behind it, people that come up with exploits and bundle them in tools that are easy to handle for criminals, and all of those type of things will take time. So it's almost like an industry has to be developed. But then, of course, once it's developed, then it starts escalating, and that's the curve that we currently are in with software supply chain attacks. And so that's why a lot of measures needs to be taken, similar to in the debit card space or credit card space, where we moved from magnetic stripe to smart cards. We need something like that in the software supply chain space, and SBOMs are probably part of that. But to Farshad's point, it's probably not sufficient. You need other things as well in addition, right?
Yeah, and so there's lots of things to worry about in terms of dependencies. You want to make sure initially that whatever package you're using is from a correct source. You want to make sure you're spelling it right, so you don't get what's the term for that?
Typo squatting,
dependency confusion. You want to make sure that even if the version doesn't change, that the package you're getting is always the same package. So you take a checksum and you check its integrity every time you download it. Browsers have that built in, but for the server side, I don't think many package managers have that built in. So there's a lot of different angles for an attacker to look at.
And
And
before I just want to mention a couple of projects that's worth for audience to check
oh yeah,
out.
please, yeah.
Links, we'll post the links in the show notes, but one of them is the Omnivore project. The other one is Sixstore. They're definitely projects worth looking into. I believe Sixstore is the one that, let's see, which is it, one of the Apache Foundation ones. Let's see here. Yeah, these initiatives have come about to try to address the software supply chain. Sixstore is the one that it is.
How do you spell it? 6 like the number?
SIGSTORE. It's a Red Hat. Yeah, it's a Google, Red Hat, Cisco. All these people have collaborated to sign, verify, and protect. So it allows you to make sure your software is what it claims to be. So it's an effort that they help with software signing and stuff like that for open source security. Great project. And then the other one, the Omnivore. That's another one worth checking out. They're also trying to map out, creating a graph of everything that's included and being able to trace lineage and things like that. Met one of the project contributors at a conference earlier this year.
Now, when I Google that, I'm not getting anything. So is it just Omnivore spelled the normal way?
It's Omni. I'll send it to you in Zooms. It's omnibor.io.
Oh, Omnivore.
Yes, it's a minimalistic scheme for build tools to build a compact artifact dependency graph tracking every source code file incorporated into each build artifact and embedding a unique content addressable reference to that artifact dependency graph, the Omnivore identifier to the artifact at build time. So really doing these things at build time so that you can create a dependency graph that can then be used with other things like SBOM. So this is not supposed to replace SBOM. It's not supposed to replace the signing schemes like things that Sixstore does, but it's supposed to create that comprehensive graph that with unique identifiers that you could create, a picture of what you have.
Oh, okay.
Yeah, because just uniquely identifying components is still one of the major problems, right? Because you could have a project, say Log4j, but for instance, a distributor like Red Hat could potentially apply a patch, right, and effectively modify it, and then you get a slightly different version of Log4j. And so there's a lot of downstream suppliers or distributors that could potentially modify or change the metadata. So it's a complex problem just identifying the components. So I think there's a lot of good work being done there.